How many guys have used Kelley Blue Book before? Or know what it's about? All right, Walker, what's Kelley Blue Book about?
It's like an online car shopping site.
Yeah, and it mostly also just gives you a general value of your car. So for example, if I click on my car's value, so I have a 2016 Subaru Forester with, I don't know, 60,000 miles on it. And I think it's one of these 2.5 premium sport utility 4D. And it's got standard equipment and it's black. So it's got pretty good condition. And I can get so it does some crunching, bless you. And it says, well, the trade-in range is right between 11,500 and 13,167. I think it might even like average that to give you a value of $12,365. So it gives you a general sense of, what to expect the value of your car to be worth. That's kind of nice. Now, so right now with 60,000 miles, it's got it's worth $12,365. What if I was to increase the mileage to 100,000? What would you expect the value of the car? What would you expect to happen to the value of the car? It goes down? Yes? Why? Yeah, so it goes down to $9,000, right? So now what I can do is I can look at the relationship between mileage and value of the car. So let's look at this. So mileage and car value. This is for the Subaru Forester. Obviously, different cars, different values, different mileage. Let's do 20,000. 15,316. 40,000.
Attention, if you have students that ride bus 8 that come in late, please just mark them tardy documented. If you have students that come in on bus 8 late.
Okay. So I've got the relationship between two things. For a 2016 Subaru Forester with standard features, I want to look at the relationship between mileage.
Sorry for the second announcement. I'm sorry, if a student rides bus 8, just leave them marked as present. Do not mark them anything, just leave them as present.
I'm just happy that people at home are getting the full Salem experience with these videos. So I want to look at the relationship between mileage and car value. So it appears that what's our acronym for looking at the relationship between two variables? LSD, that's right. LSD. What does the L stand for? Linearity. Whether the relationship is linear. What does the S stand for? Strength, right? Whether the relationship is strong, moderate, or weak. And what about the D? Direction. And Allison, the direction can be, what are the two possible directions? Harrison? Yeah, and what can we tell so far about this relationship? Anyone tell me? From the LSD? We know the direction is negative, right? Which means as one variable goes up, as the mileage increases, what happens to the value of the car? Decreases, right? Goes down. So the direction is negative. Now, I want to see if it's linear or not. So I'm going to show you how to do this on the calculator, but I'm also going to show you how to do this on the computer. So on your Chromebooks, I want you to go to Staplet. It's like applet, but for statistics. So ST and then applet. Staplet.com. Staplet.com. And under data analysis, click on two quantitative variables. And it should take you to this page. Raise your hand once you're there. Once you are there. Okay. So mileage is my explanatory variable, and price in US dollars is my response variable. All right, so 20,000, 40,000, 60,000, oops, 80,000, 100,000, and 120,000. That's my, all right, 15316 is my first one. Let's see if I can make it bigger so you can see better. 13904. Don't put commas, by the way, on this. 12365, 10720, 9015, 7338. Data should look like this. And I'm going to hit begin analysis, and I'm going to take a look at what that looks like. All right. Raise your hand if you have something that looks ideally exactly like this. Exactly like this. Okay. So we are ready to address the LSD again. So with your neighbor, go ahead and, like, from an LSD perspective, How would you describe this graph from an LSD perspective? All right. So, Ethan, what do you think? Linear, negative, and very strong, right? If I draw a line through this, how far do the points deviate from the line? Like almost none, right? So make a prediction. What do you expect the correlation coefficient to be, your R? What do you expect the correlation coefficient to be for this one? Camden, what do you think? Negative 0.99. So Camden's predicting negative 0.99. Is the correlation coefficient of -1 strong or weak? Strong. Very strong, right? Anything that's close to -1 and 1 is very strong. So this is very strong. That's a terrible very. So this is very strong, and this is also very strong. So, all right, if you go back to here, you can go down and you can actually click calculate correlation. There you go, negative 0.99999. Did you do that beforehand or? Okay, so that was a good guess. It wouldn't have surprised me if it was going to be like -1, in fact. But it looks like there's just enough variation. Okay, click on the calculate least squares regression line as well. All right, looks like it's not perfectly hitting, but like, dang, that's pretty good, right? Certainly looks like a line. All right, let's write down my equation. So I'm going to write it this way. Y hat is negative 0.0803x plus 17063. Okay, and there's two components to this. There's that. What does the negative 0.0803 represent? The slope. Now, with the people around you, in words, in the context of this problem, what's the meaning of negative 0.0803? What's the meaning of that? So with your neighbors, share what you think the meaning is. And then also try to figure out what the 17063 stands for. Like, what does the 17063 represent in the context of this problem? In the context of that problem. So who can tell me what the negative 0.0803 represents? Anyone want to take a guess? Ryan.
For every mile that you add, it goes down negative, or it goes down 0.083.
Yeah. So for each additional mile driven, right? For each additional mile driven, bless you. For each additional mile driven, who can tell me that second part? Ryan kind of gave you a hint. For each additional mile driven, what happens? Yeah, the cost of the car goes down by, tell me like in like simple words. Say it again. 8 cents, right? For each additional mile driven, the price of the car goes down by 8 cents. Price of car decreases by 8 cents. We know it decreases because it's got a negative slope, right? How much? 8 cents per mile. That's the slope. Slope is a ratio. So this is negative 8 cents per mile. Rise over run. Rise is negative 8. Run is 1. So for each, as x increases by 1, y decreases by, in this case, 0.08. What about the 17063? Evan, what do you think? Yeah, and so that is the y-intercept. Who can tell me in like the context of this problem?
How much the car's worth if there's no miles on it?
That's right. Like the brand new, if there's no miles on the car, right? Brand new, a 2016 Forester would be worth $17,000.63. So with no miles driven, no miles driven, brand new, value of the car. A better sentence would have been the value of the car with no miles driven, as opposed to the other way around. Make a prediction for the value of a car with 150,000 miles on it. Make a prediction for the value of the car with 150,000 miles on it. And then share with your neighbor once you have that. All right. Emma?
5,018.
5,018. How many guys got that? 5,018. So we plug in 150,000 in for x, right? Negative 0.0803 times 150,000 plus 17,063. Now, I really like Staplet for this kind of analysis. On the IB exam next year, you will need to know how to do this using the TI Inspire. So I'm going to show you how to do this using the TI Inspire calculator. Okay. So that one might or might not work. It does? Excellent. So you will need to start a new document and then add lists and spreadsheets. So raise your hand if you have successfully done that. So click on, and then new documents, and then lists and spreadsheets. Raise your hand if you are there. If you are there. Okay. So what is my x-axis? What's on my x-axis? Tell me. So call it miles x. And the other one, value y, value e. And now put your data in. So I'm going to move to the side so that I can see my data. 20,000, 40,000, 60,000. Let me know once you have put the data in. Put the data in. 20, 40, 60, 80, 100, 120. Once you have, move your cursor to the right of both columns. So like ideally you would be in C1. Move your cursor out of, to the right of both columns. So you're like in C1. Okay. Now you're going to go to menu. You're going to go to statistics, statistical calculations. And I want linear regression mx plus b. Y equals mx plus b. My x list, hit the right arrow, and that's going to be my miles x. My y list is going to be my value y. So from your spreadsheet, you're going to do menu 413. And you're going to select your x list to be miles x, your y list to be value y. Raise your hand once you're there, once you're with me. Mostly. And you'll have opportunities to practice this. All right, and then you hit OK. All right. Which of these is your slope? Your The m is the slope, so there it is. Slope is 0.0803 if we're rounding to 3 sig figs. There's your y-intercept, 17,063. And your correlation coefficient is not r squared. You need to go down to r. There it is, negative 0.9994. So there's your correlation coefficient. Right. Let's do one more thing from here. So from here, do control and add a new page. And then go to data and statistics. So lists and spreadsheets allow you to put the data in, and then data and statistics allow you to do some analysis. All right, so now I have my data. It should be all over the place. Go down here. What variable do I have on the bottom? Your miles x, bless you. And then go over here and click on value y. And that gives you a scatter plot. So if you need to draw it, it gives you a sense for what it looks like. And in general, you want to know what your data looks like. From here, go to menu. I want to analyze. I want to analyze regression. And I want to, again, show linear mx plus b. So it will actually also, if you want to, you can go to here and it will give you the equation like that, which is kind of nice. Now, what's the one thing this graph won't give you that you might need? Huh? Yeah, the correlation coefficient. That it won't give you that. But it will give you a graph and it will give you the equation. So, one more thing. Let's talk about significant figures. Significant figures. We're getting to the point where we need to talk about rounding to a certain number of significant figures. So in general, 3 sig figs. That's going to be our norm. Our norm is going to be 3 sig figs. So 2.4578. If I want to round that to 3 significant figures, what is that going to be rounded to 4 significant figures? 2.46. So I look, here's one significant figure, second one, third one. So 2.46. Quick question. How many sig figs does this thing have? 5 sig figs? So 5 sig figs. The zeros, if they are in between 2 non-zero numbers, count as significant figures. How many sig figs does this thing have? 1 significant figure. Zeros that follow a non-zero number just by themselves don't count as sig figs. So 1 sig fig. What about this? How many significant figures does this thing have? One significant figure. So 1 sig fig. Zeros that precede a non-zero number don't count as sig figs. What about this? This is a little tricky. This thing has 3 significant figures. So 3 sig figs. So round this to 3 significant figures. Round this to 3 significant figures. To 3 significant figures. Andrew, what do you think?
0.99.
You said 99? That's 2 sig figs.
0.987.
987 is 3 sig figs. Okay. So, what I want you to do, using your calculator, give you some calculator practice. I took 2 IB exam problems. Where you're given a data set, you're asked to find the correlation coefficient, the line of regression, and then make a prediction. So you're given a data set, correlation coefficient, line of regression, and make a prediction. So work those out.